So we're going to do density, the third part of our series. We've looked at finding the mass of objects. We've looked at finding the volume of objects. The last thing we need to do is use this equation, this formula, that tells us density of an object is its mass divided by its volume. So how much of the space it takes up, how much does the mass take up space? Okay, something that's denser will have the mass in a smaller volume. Okay, so a lot more mass. And something less dense will have less mass in the same volume. And we looked at that with our cubes, but let's do some calculations here. So, bring you up a little bit closer with my board here that I've done. You can see some of the results from our last couple of videos. So, firstly, we've got our cubes. That's all these ones. They all had the same volume. Their volume was 15.625. which is approximately 16. 16 was what we got from displacement. 15.625 is from measuring. We're going to use that one because that's more accurate. This one's easier with number wise. Okay, so I'll show you how to do this. We'll do a couple together. Let's start with the copper. So the copper, its mass was 148.5 grams. And our volume, 148.5 on my calculator, divided by 15.625, which equals 9.504. Okay, so its density is 9.504. I'll leave that out. Grams per cubic centimetre or grams per mil. Okay, let's look at another one of the metals. We look at aluminium. So copper, that's its density. Let's look at aluminium. So aluminium, in the same amount of space, only had 44 grams. So let's do 44.27 grams divided by 15.625 equals. Okay, and I'll hold it up to you, and you can see that its mass, its density is 2.83 grams. Okay, so 2.833. Okay, grams per cubic centimetre. So we already could tell if you were holding it, you'd go, hey, copper is heavier than aluminium in the same volume. This one's heavier than that one. This is more dense. This is less dense. Okay, so we can do that. That's called a measurement that is qualitative. We're making a judgment on things that we can notice about it. But it's not as accurate as measuring. With our numbers here, we can see that the copper has a density around 10, whereas aluminium has a density around 3. So we can compare with numbers, and that gives us a much better way of comparing how much more dense something is. Okay, so we do that for the rest of these. I'm going to give you this to work on at home, give you these results typed up, but now you know where they've come from. Second thing we're going to do, though, is down the bottom, I've got my eraser pracs. The same thing, their mass, their volume, let's find their density. And particularly, we want to know if our unknown one, the rubber that says yes, no, maybe, maybe, is that one a Staedtler rubber? It's the same colour. Probably not the EF one because it's a different colour. Or is it a study mate, which was my bet because it looks very similar. And so if it's a study mate, it will have the same density as the study mate one that we know. So it's our unknown rubber, but we think it's this brand. So let's go through and figure out. So EF is 13.78 divided by 10. So its density is 1.378. Okay, Staedtler, the next one is 23.78 divided by 16 equals 1.486. Okay, my unknown is next. I wrote them around the wrong way. 24.49 divided by 12 is 2.041. I've got to round it up. Okay, and my study mate is 24.90 divided by 13 equals 1.915. Okay, so having a look at my results here, I can see that, let's just round them up to the nearest whole number, or even the second decimal point. So this is 1.4, this is 1.5. So if I use that hundredth on there and round it up from there, that's 2, and this is also 2. Okay, oh, sorry, 1.9, so very close to 2. So it does make sense that it could be, this unknown possibly could be a study mate because it is a similar size. So it is a similar, very close to density as each other. Could be a completely different brand I haven't tested. But that's a usefulness of knowing density of things. And that's actually how the king, and I don't know which city he's from, in the story of Archimedes, how Archimedes figured out how the king could tell if his crown makers were actually cheating him. So he was able to tell the volume, the density of the gold he gave, and whether the crown had the same density as gold. So that meant that he could, I think they were wrong, they had been doing it, and so he could prove it, and therefore they got into a lot of trouble. All right, happy story. I'll give you the rest of these to have a look at, and we'll think of a few other things to do with density, including an experiment to find the density of ice.